All right, so our objective today is to understand how to translate into an inequality we're going to learn specific situations and how we define variables. And we're going to review solving inequalities. Okay, so that's what we're going to talk about today. So what I want to do is talk about the 4 different types of inequalities and what kind of phrases might you hear that you would translate to that particular inequality. Okay. Now what's strange is we've heard the phrase less than, which didn't tell us an inequality, right? It told us subtracting and switch the order of what we had. So how are they going to present that phrase telling us we're going to write a less than symbol as opposed to us writing it as a subtraction? So does anyone have an idea what you might hear in your word problem that would tell you, oh, they want an inequality symbol, not subtraction and switching order? Ian?
It would be like less than 24 rather than like 24 less than.
Well, you're always going to have 2 numbers, so something in front and something behind. So I'm not sure I quite agree with just less than, because I think we would interpret that to mean subtraction. Okay, what do you think, Allison?
Maybe you have is less than.
That is exactly it, because remember equals is, so that is becomes a component as for our inequality symbols. So the phrase that you're going to hear most often is just going to be is less than.
Wait, is this less than or equal to? Or less than?
Nope, this is just a less than symbol. I will box it. There. Okay. So what phrase might you hear that's going to tell you you're going to write a greater than symbol? Okay, Brian?
Is greater than?
Yeah, you're going to hear something like is greater than. Okay? So is less than tells it's a less than inequality. Is greater than tells us it's going to be the greater than inequality. Now, where it gets really interesting is the greater than or equal to, less than or equal to. Oops. I've got a couple of phrases that show up commonly. And they're not going to be using the is less than, is greater than. They're going to be using is going to be part of them. Okay, that's for sure. Do you have an idea, Patrick?
At most or at least.
Okay, that's where we're going to get those kinds of words, at most and at least. So if I want something to be equal to this number or greater than that number, would that be is at most this number or is at least? Yeah, is at least. At least means it could be larger, and that's what greater than would mean. It could be larger, okay? Now this one is a little tricky. It's kind of a negation of something else. Is no less than. When we add that, it's said this is as small as it gets, and it can't be any smaller than this, so it could be bigger, okay? So using those as kind of our role model, what would be some phrases that would tell us to write the less than or equal to symbol? Okay? Ethan?
Is at most?
is at most. So this is the maximum it could be, which means it could be smaller, is at most. Okay? And then what would be the other one that kind of mirrors what we had for the greater than or equal to? Spence?
Is yes greater than?
No. No, yes. Interesting thought. Molly. Is no more than. Or is no greater than. So we have a lot of variations, but no, not yes. No yeses. That was cute. Okay, so our word problems are going to tell us to solve, and unfortunately, we do need to write these. So the first one, a bakery makes bread in which the ratio of whole wheat flour to white flour is 5 to 2. In reality, it's very challenging to make a completely whole wheat flour bread because it's very heavy, very dense. It's like a doorstop. So they have to mix in some white flour to kind of make it lighter and not like you're eating sand. Okay, that's not people have figured it out, but a lot of them use a whole wheat white flour, which is kind of an interesting mixture. How much white flour is used in making a batch of bread containing, and here comes the key phrase, at least 35 kilograms of flour. All right, so a couple things. Number one, what kind of inequality do you think we're going to use? There was kind of a giveaway phrase that told you what of the inequality signs we were going to use in this one. Maddie, what do you think?
Greater than or equal to?
Okay, and what tipped you off? That's going to be it.
At least.
Okay, so we are going to use greater than or equal to because of the words at least, meaning it could be more. Notice it didn't have the word is with it because sometimes, or it actually is there, way back after how much white flour is used. So remember, when we're doing symbols that mean equals, we're using verbs to help us write them, and then this additional tells us exactly which inequality. Okay, great. So the other thing I want to talk about is this notion of ratios. Now, the order of the numbers corresponds to the order that the words were given. So what do you think the 5 corresponds to? Whole wheat. Okay. So we've got the whole wheat is going to correspond to the 5, and then the white is going to correspond to the 2. Okay. Now, when they say that it's in this ratio, that's not how much is being used, right? We don't know exactly how much is being used, but what do we know is true about all ratios? What do we always do to a ratio? Oh, I always do ration. What do we always have to do to ratios? By the way, what's another word for ratio? Fraction. So what do we always do to fraction answers? Reduce to lowest terms. So ratios are reduced to lowest terms. Well, how much was our original ratio reduced to get to 5/2? Do we know? No. So what we're going to do is let x represent the amount it was reduced. So here's how I do my definitions. I'm going to take my wheat flour, multiply it by x, and that's the amount of wheat flour. Now I'm going to multiply the white flour. Oh, that says while. It should say white way back there. Sorry about that. I'm going to multiply the white flour ratio number also by the same value x, because that's what I divided out of top and bottom to get to 5 halves, and that's going to be the amount of white flour. Okay? So, how do you think I'm going to set up the equation or inequality for this particular problem that's going to demonstrate making a batch of bread containing at least 35 kilograms of flour? Okay? Molly, what do you think?
5x plus 2x equals 35.
Ooh, careful. Equals?
Is greater than or equal to.
Very good. The 35 represents both flours mixed together. 5x represents the amount of the wheat flour, whole wheat flour, and the 2x represents the amount of the white flour. So then we just go ahead and solve this. So I get 7x is greater than or equal to 35, divide by 7, write my answer over here, and I get x is greater than or equal to 5. Now, x represents that factor that I reduced by. So it could be 5 or it could be more. So minimally, it's 5. So what I'm going to do is take that, and I'm going to multiply both of these by 5. So this is the minimum amount of flour I would have used. So 25 kilograms of whole wheat, 10 kilograms of white. So which of those two answers does my question actually ask for? It asks only for the white flour. So we're going to take this number, and this is how we write the answer. This is going to be more of a sentence because of the fact that it's not just that number. It could be that number, it could be a different amount. So we're going to say that we need at least, so mirroring those words, 10, the label was kilograms, white flour. Because we actually don't know the exact amount that was used to make the batch. We know it was a minimum of 35, but it could have been more than that. Okay? Does that make sense? Yeah? Okay. Number 2. Yes?
Do we have to write down the word problem in our homework?
Only if it helps you figure out the equation. Otherwise, I'd just be writing down the definition, the translation, and going from there. The sum of 2 consecutive integers is less than 75. Find the pair of integers with the greatest sum. Okay, the sum of 2 consecutive integers is less than 75. Find the pair of integers, looks like vinegar, with the greatest sum. Okay. All right, first off, what inequality symbol am I going to use, and what words tell you that's what you're going to use in this one? Amanda? Huh? Okay, and what gave away you were going to do less than?
Is less than 75.
Yeah, is less than. Okay, so we're just going to use a less than symbol. Okay, so what I want to talk about are consecutive, the idea of consecutive integers. And we'll just talk about consecutive first, and then we'll talk about consecutive even, consecutive odd. So consecutive numbers would be like 1, 2, 3, 4, and so on. So you're not going to know 1, 2, 3, 4, and so on. You're going to have to figure out if it's 1, 2, 3, 4, and so on. So our job is to be able to define these. So by default, what we're going to do is take the first one and call him x. So we would say that's the first consecutive integer. Now, what am I doing to the first one to get to the second one? I'm adding 1. Now, this is where it gets a little bit interesting. How do I get to the third one? Not from the one before, but from the first one. Our reference point is always the first one. Ian? Would be x plus 2. And how would I get to 4 if I started with 1? X plus 3, and so on. So that's what consecutive integers look like. Now, consecutive even, consecutive odd. And I'm just going to abbreviate integers because of my spacing here. So that would be, even would be 2, 4, 6, 8. Odd would be 1, 3, 5, 7. Okay, so we're going to allow the first guy to be 1. With the evens, what do I do to the first number to get to the second number? So what do I do to 2 to make it 4? Plus 2. What do I do to 1 to get to 3? Doesn't matter if it's even or odd. I'm skipping every other number. So the pattern to get to the next one would be the same, regardless if it's consecutive even or consecutive odd. Okay? What do I do to 2 to get to 6?
4.
Add 4. What do I do to 1 to get to 5? What was that? Add 4. The pattern is the same. Okay? And then what do I do to 2 to get to 8? What do I do to 1 to get to 7? So right there, there's all your definitions that you need, whether they're consecutive, consecutive even, consecutive odd. Okay? So this one talks about 2 consecutive integers. So knowing that, what are going to be my 2 variable packages I'm going to use here? First guy's easy. Doesn't matter what kind it is. First integer. Okay. Now, with consecutive, what would be the second one? X plus 1, because it's one right after the other. Now, the word integer means what kind of answers can I not get? Can't get fractions and decimals. Now, what does it tell me to do with those 2 consecutive integers? It says I want their sum, which means I'm going to add them. And we said less than, because it said is less than, and then 75. So now we go ahead and we solve this. I have some like terms, and I have 2x plus 1 is less than 75. I'm going to subtract 1 from both sides, and I get 2x is less than 74. Divide by 2, and I get x is less than, 2 goes into 7 3 times, which is 6 with 1 left over, and 2 goes into 14 7 times. All right. Now we have to think logically about what they ask us to solve. It said find the pair of integers with the greatest sum. So to find the 2 that have the greatest sum, I should be looking for the 2 greatest integers that meet this condition. So my number has to be less than 37. What integer is less than 37? So I'm going to write my answers here. My smallest one would be 36. If he's 36, what would the second one be? 1 more, or 37. And that's how I get my 2 answers. The reason why they had to specify which pair had the greatest sum is because there's quite a few pairs that would meet this condition of being less than 75. And when you go integer-wise, that means you could have negatives, which could be an infinite number of pairings. So they told you, we want this particular pair that meets this condition. Amanda?
How come X wouldn't be 37?
Because my answer says x is less than 37. So if it said less than or equal to, yes, it could have been 37. Because it said less than, I have to go to the integer in front of it. Okay? All right, let's see. Ooh, we probably won't get one more in there. We might try to. All right, right quick. A student receives or received grades of 83 and 95 on his first two tests, what grade must he get on his third test to have an average of no less than 90 degrees. 90%, sorry about that. Woo. What inequality are we going to use on this one? Greater than or equal to means it could be more, no less than. What math are they actually doing in this problem? They're doing average. So to do an average, you take the grade. Oh, we got to define our unknown. What's our unknown in this problem? X represents what?
The third test.
Score on third test. So to do averaging, we take the scores that we know, add the third test, which is the unknown, divide by the number of tests we took, 3, that's how we do average, and say that's greater than or equal to 90 degrees. 90%, sorry. There I go again, sorry. Okay. I'm going to tell you to solve this out, and I want you to finish that, but I'm going to give you the answer. The answer would be at least a 92. So if they scores a 92 or greater, then they will get that 90%.